Okay, you are forewarned. This is going to be 2 lessons in one. So we're going to be talking about 9.4 and 9.5 because the way that I've always taught this is teaching all the ratios at once. It just makes more sense to do it that way because it's a process that you go through figuring out what you have, what you don't have. So what is a ratio? Well, a ratio is a fraction, right? It's a comparison of two things. So you're comparing using a specific ratio. And those ratios are called tangent, sine, and cosine. So welcome to trigonometry. This is basically right triangle trigonometry. And we're going to be talking about tangent ratios, sine and cosine ratios. And then we're going to use those to solve for problems. This is going to be a little bit of a longer lesson, so bear with me, but I'm going to try to go a little slower when I explain this because it's going to be very different not explaining this in front of you. So let triangle ABC be a right triangle with acute angle A. So when I say tangent A, this is actually the degrees. Okay, so this A refers to the degrees, and that's how I'm going to set this up. I want to look for the length that's opposite of angle A and adjacent to angle A. So opposite in this case is going to mean across, and adjacent means next to. We've gone over adjacent before. So let's take a look at the triangle that's actually on my examples that you probably, I know you don't have a packet for, because before we left school, you didn't get access to that, unfortunately. So here's how I do trigonometry. If I'm looking for, well, first of all, I've got 2 acute angles. Let me start there. I have 2 acute angles, right? I have my right angle and I have 2 acute angles. And this is hypotenuse. And from this angle, this is the opposite side. From angle A, this is the opposite side, and this is the side that's right next to the angle. Actually helps make up the angle. So from that angle. Now, if I was doing it in the opposite direction by using angle B, I would call this one my opposite, which would make this one my adjacent. Once you identify in trigonometry what you have and what you don't have, it makes it really easy to figure out how to set up your ratios. Okay, and the ratios is just like a proportional problem. So that's why I say ratios, because you are looking to set up a proportion. So from this angle, opposite, adjacent, hypotenuse. From this angle, opposite, adjacent, hypotenuse. Okay? All right, let's take a look at this. So I'm going to find the tangents of this. And when I say find the tangents, I'm actually going to round this to 4 decimal places. You don't have this, so you can't read the directions. It says find the tangents of the acute angles in the right triangle. Write each answer as a fraction and as a decimal rounded to 4 places. So I want to find the tangents of these angles. So tangent is opposite over adjacent. I'm going to put all these together eventually. Okay, it's just SOHCAHTOA. And when I do it, you'll be like, oh, that's what she meant. Okay, so tangent is opposite over adjacent. So from this angle, the opposite of that is 24. So 24. And the adjacent to that, not the hypotenuse, never the hypotenuse. The adjacent to that is 45. Okay, oops, you can't see that. Move the paper a little. Not that much. Okay, so this is the tangent of that angle. And we're just learning how to set this up. That's an S, not a 5. We're just learning right now how to set this up. If I'm looking for the tangent of R, I'm doing a different angle now. I'm going to look for the opposite, 45, over the adjacent, 24. And remember I told you that we're actually doing these as proportions? And you're like, well, you're missing something. No, I'm not. I can throw a 1 under here. Okay, and cross multiply. And when you have degrees with these are actually just numbers. So if I was to do like tangent 45, that's an actual number. Okay, so let's keep going. See what we come up with here. All right. Let me get this so you can see it. All right, so find the tangents. So from L, that would be 5 and 7. So tangent L, 5 over 7. Oh, I forgot it says to do decimal places on this. It's just a division of these two numbers, 5 divided by 7. So did I do it on that? Yeah, I did. I'll show you the paper I already did that on in a minute, just to show you it's just division. And the tangent of J is opposite adjacent. So tangent J is 7 over 5. Okay, last one of these. Notice I'm using the acute angles. I'm not using the right angle ever. Never use the right angle. Okay, we will eventually use the hypotenuse, but we're not using the right angle. So for C, that's the tangent of C is going to be equal to opposite over adjacent. And of A, that's going to be opposite over adjacent. So 2 over square root of 2. Now, technically, that's not okay. You can't leave a number like that, but we would actually be dividing that number right there. And so we're not going to leave it like that, because in the end, these are the ones I did before. Okay, you divide these. So 45 divided by 24, and 24 divided by 45, and 5 divided by 7. Remember, this is a ratio, and a ratio is something that when you do this, you are comparing. So in all of these, the last step is just to divide. Okay, so I've already done those. All right, let's keep going. So now I got a degree. You're like, oh, yay, a degree. So when you're doing these, identify what you have. Now we are still using tangent for all of these. So remember, tangent is going to be opposite over adjacent. And I'm writing it like that very specifically, because that means tangent of the degrees is equal to the opposite side over the adjacent side. So tangent of 10 degrees is equal to the opposite side over the adjacent side. Now you're probably like, well, how do I solve that? Well, there's a really cool trick to this. You just switch their places, because it doesn't matter if you multiply x times tangent of 10 degrees or 10 degrees times tangent x. Eventually, you have to divide 5 into it. So you just switch their places here, and you go, okay, well then x must equal 5 divided by tangent 10. Now you're like, well, how do I figure that out, right? Because you may or may not have a graphing calculator with you. If you downloaded the one I showed you online, you have access to one that looks just like this. And if you look at these right here, that's your tangent button. And we'll be using the inverse too. But that button right there is your tangent button. So to find this, you're just going to do 5 divided by, okay, 5 divided by, and then you're going to hit that tangent button, and it gives you tangent, and you're going to put in your 10 degrees. And you do not have to end that with a parenthesis, and it gives you 28.3564091. So 28.4. And that's how long that is. Okay, let's try it again, because I know with the first example, you're going to be like, I don't know what you just did. Okay, but I'm going to tell you right now, if you have x on the bottom, you are going to divide, because it'll make it so much easier for you. All right, if you just know that little trick. Like seriously, way easier. All right, so let's take a look at this one. You have 64 degrees. Probably should have circled this angle. It's part of my steps that I like to tell students. And you're looking for opposite over adjacent. So opposite and adjacent, use tangent. Opposite, adjacent. Again, figure out what you have so you can figure out what you don't have. That's how you're basically doing these kinds of problems. So tangent 64 equals x over 13. Now, if this is in the top, the numerator, you multiply. Okay, remember you're just doing cross multiplication here. So x equals 13 times tangent 64. When you put it in the calculator, always number first. Okay, if you don't put in the number first, you're going to get a funky answer because it's going to think you're actually doing tangent 64 times 13. And so it's going to multiply the 64 to the 13, then take the tangent. So make sure you do the number first. So 13 times tangent 64. Okay, hopefully you can see that. It was 64. Okay, and then you just hit enter, and there's your answer. So that side is 26.6, so 26.7. Okay, last one of these. Again, remember you're using tangent here. Just happen to know that, but you're going to find out how I know that so easily because I'm not doing anything with the hypotenuse. Tangent is the only ratio that doesn't have anything to do with the hypotenuse. From the angle that I was given, this is my opposite, and this is my adjacent. And then this is my hypotenuse, which I'm not going to do anything with. But this is opposite, adjacent, hypotenuse. So tangent 31 is equal to opposite over adjacent. Okay, and I told you when it's in the bottom like that, you're going to divide, right? So you're going to divide, you're going to switch these two places, and you're going to divide this, and you're going to get x equals 24 divided by tangent 31. Okay, so 24 divided by tangent 31. 39.9. It says round to the nearest tenth, so 39.9. So this is 39.9. Okay, so that was just tangent. That's all that was just tangent. It's one of the ratios. Sine and cosine are also a ratio that we're going to be using, but I have a couple more tangent examples, and then I think I have one coming up that is a sine and cosine examples coming up. Okay. Oops, I lost my marker. So, an environmentalist wants to measure the width of a river to monitor its erosion from the point she walks downstream. So she starts out at point A, right? And she walks downstream, and she walks downstream this way, 100, I think it's meters, isn't it? Feet, no, 100 feet. And then she ends up over here. And from that point, she knows that the angle that she's looking across to point C, which isn't even on camera, okay, that angle that she's looking across, she knows this is 40 degrees. Okay, she's able to measure that. Because what she wants to find is how wide is the river. So environmentalists go out and they take these measurements so they can figure out how wide something is, or what's happening to the environment, or did the river become wider? Is there flood stages coming? Anything like that, right? So this is actual real life stuff here that people actually go out and do as a job. So I got my angle, it's 40 degrees. I got X that I want to solve for. I want to solve for how wide is this river. And so opposite over adjacent. So I'm going to use tangent 40 equals X over 100. X is in the numerator, which means I'm going to multiply, okay? Multiply. You can't see that, but I wrote multiply. All right, so X is equal to 100 times tangent 40. If you put that in the calculator, you should get 83.9 feet. That is how wide the river is. Now here's where we get concerned. Because a year later, she goes and does the same exact thing in the same exact points. But this time, it's 51 degrees. So instead of tangent 40, we're looking at tangent 51. So tangent 51 is equal to X over 100. That's the only thing that changed. How wide is the river now? Well, it's 100 times tangent 51. And that means the river is 123.5 feet. So that's only a year later. And it says how many feet of the width of the river did it increase? Well, for that, I just need to subtract. I need to do 123.5 minus 83.9 to get 39.6 feet. So as an environmentalist, if I have erosion of that much, I would be really concerned that I had 40 feet of erosion. Okay? All right. So now we're looking at, that was all tangent, by the way, opposite and adjacent. Now we're looking at this boy. Angle of elevation means looking up. I'll go over that a little bit further down this lesson. Like I said, this is going to be a long lesson, 2 lessons in 1. So just hang with me, pause, go to the bathroom if you need to. You got a boy, he's flying a kite. So he's got this string right here. The kite reaches its maximum height of 300 feet away from the boy. So what is the maximum height of the kite itself? Okay, you draw a little triangle. So he's holding on to this. He's got the 300 feet of string. He's looking up at 18 degree elevation. And I want to know how far the kite is off the ground. So you should notice something right away. You should notice that we're using a hypotenuse. So this right here, that angle, I have opposite and hypotenuse. And this is my adjacent. So I'm no longer using that. So we are going to use the ratio for sine on this one. Like I said, you're going to get to know these really well because you're going to use them a lot. So I'm going to use sine, which is spelled S-I-N-E, but we abbreviate with S-I-N. So it's not sin, it's sine. Sine 18 degrees equals opposite x over hypotenuse 300. So x is going to equal 300 times the sine of 18, and that is 92.7 feet off the ground. Okay? All right, so let's talk a little bit about all 3 of these because I'm about to introduce you to sine and cosine. I know I just briefly did sine, but I'm going to introduce you to sine and cosine. So when you have a problem, you should write out so, ka, to, These are your three trigonomic ratios. So if I was in class right now, they would be literally right behind me on the wall. So sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse, and tangent, opposite, adjacent. So when they're referring to this, it refers to the specific angle. So right now they're talking about angle A. And they're talking about the opposite side being all the way across, the adjacent side, and then the hypotenuse. So if you're using sine, you would use opposite and hypotenuse. If you're using cosine, you would be using adjacent and hypotenuse. And if you're using tangent, you would be using opposite and adjacent. Okay, so what side you have matter. And what you pick out here is how you can actually solve these problems. So if you just write this real quick on a problem, or just even on a scratch piece of paper, and then you learn to cross it off, I'm going to show you how to do that. It'll make things so much easier for you just to know that that's how you go about doing it. Okay? All right, we're going to do some examples of this, but first we're going to talk about the sine and the cosine. So they're kind of inverses of each other in a way. If you have this angle right here, F, and I'm doing the sine of F because it asked me for the sine and the cosine of F and G. So that's what I'm doing right now. So the sine of F is 12 over 13. Okay, opposite, hypotenuse, opposite, hypotenuse. And the sine of G is 5 over 13. And this equates to a number. So if you're like, well, I don't get what sine and cosine and all this stuff is, it's just a number. Just like pi is a number, this is just a number. A little blurry, a little better. Okay, so that was of F. And then, oh, sorry, that was F and G. And then G, you're looking at cosine of the F and cosine of G. So cosine F is equal to 5 over 13, right? Because it's, no, it's not. Cosine is 12 over 13, adjacent to hypotenuse. 12 over 13. So that's 0.9231. And the cosine of, oh wait, it was because it was this one. It would have been easier to just change that into a G. But let's do this up here so I don't get myself confused again. Cosine of F is 5 over 13 or 0.3846. Sorry, I'm doing F. Adjacent hypotenuse. Okay, adjacent hypotenuse. See, I switched colors and then whoop, they went in my brain. So the cosine of G, adjacent hypotenuse, adjacent hypotenuse. So you're looking at 12 over 13, which is 0.9231. Okay. All right. Because this video is going to be so long, I've already done these and I'm just going to show you the answers if you want to pause the video and take a look at what I did and kind of mull over what this looks like. This is the sine of F, 65 over 97, and the sine of G would be 72 over 97. And you can see here when I said they're inverses of each other, opposite angles, sine and cosine, see how they're the same? So that's the kind of thing that you're comparing. And then when you get to this one, they're all the same. They're all exactly the same because it's a square, right? If you continue this triangle, that would be a square. So these are 45, 45. That's one of our special triangles that we talked about. Okay, so please take a look at that if you need to look at that further. No problem. You're on a video, you're watching a video, so you can stop this. And I realize even right now I'm at 25 minutes. So I may break this video up just so that you guys can have a break. I don't know. We'll see. I don't like talking this much. You know that because in class I don't like talking this much. But circle the angle, okay? And I want to find x and y. So the first step in solving these is to circle the angle and write out SOHCAHTOA. And it'll help you figure out which ratio you're going to use. Because to solve for either of these, I have the hypotenuse, right? The hypotenuse is 9, and I have the hypotenuse. So I'm going to be using sine and cosine. I don't need to use tangent at all. I have a hypotenuse, so I'm going to use sine and cosine. Now, when I actually use sine, I'm going to be solving for the opposite side. So sine 16 equals x, opposite of that angle is x, over the hypotenuse. So x is equal to 9 times sine 16, which equals about 2.5. Now when I do cosine, I'm going to use the hypotenuse, but I'm solving for the adjacent side. So I'm solving for y here. Okay, I have the hypotenuse, that's what I'm going to use, and I'm solving for the adjacent side. So cosine 16 is equal to y over 9. So y is equal to cosine 16 times 9. I forgot my 9. So that is about 8.7. Okay? Notice that both of these numbers right here are smaller than the hypotenuse. That's how it should be. That's a really, really good way of checking yourself. If those numbers are smaller than the hypotenuse, you're good to go. Okay. I think I'm going to do one more example and then stop this video and then start up another one, so like a part B, so that you can get the rest of the notes on angles of elevation and all that kind of stuff, because this has already gone on for 27 minutes of me talking. Okay, so step 1. SOHCAHTOA. Write it out, circle your angle. Okay, from that angle, what do you have? Well, from this angle, this is the hypotenuse again, right? You can label your sides. Opposite. This is your hypotenuse. Really sloppy. And this is adjacent. Okay? So what do I have? I have the hypotenuse. What am I not using? I'm not going to use tangent again. I'm going to use sine and cosine, which makes sense because that's how this particular lesson was set up. We're into the next lesson at this point. So sine 72 and cosine 72. So sine 72 is going to equal opposite, which is your n, over 50. Cosine 72 is going to equal your adjacent, m, over 50. And then once you solve these, you'll have 47.6 and 15.5. Okay, we are at 29 minutes. I'm going to stop this video. I'm going to continue the rest of the examples. You have no idea how many more we have, but we have 2 more on this page. We have a couple of word problems. We have me talking about a process that you can use. And then we're going to talk about elevation and depression. So come back for part 2 of the video. It's going to start whenever you're ready. And I will get it done right now so that I can make sure to try to post both of them together.